Dr. Bbosa Science, Kwano Kabeti Science, Love ya Bbosa Science, Truth in Beta, Truth in Omega, Truth in Alpha Science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Ssomero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr. Bbosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A level, we teach sciences only. At O level, we teach arts and sciences. Today, we are going to study aromatic compounds. These include benzene and compounds that resemble benzene in behavior. Benzene, chemical formula is C6H6. Benzene is a cyclic compound with delocalized conjugate double bonds. That is, the double bonds are free to move through the whole molecule. The structure of benzene can thusly be represented as C, 6 carbon atom in a ring, double bond, double bond, double bond, single bond, double bond, double bond. What we call conjugation. Double bond, single bond, double bond is what we call conjugated double bonds. On each carbon atom, we can put a hydrogen atom. We have been told that the double bond are free to shift from one place to another. So sometimes we can write a double bond there, single bond there, double bond there, single bond here, double bond here, then a single bond there. Or we can write it as in a small short or in a simpler form. We can write a benzene ring as double bond, double bond, double bond, or we can write it as, since the double bond are free to shift from one place to another, we can write a double bond there, then a single bond, then a double bond there. Or you can still write it as benzene with 6-membered ring, and then you put a circle indicating that the double bonds are delocalized. Effect of delocalization of double bond in benzene. One, the benzene ring is very stable, and in most chemical reactions, it is preserved, it is not destroyed. It remains as a benzene ring in the products. Two, all the 6 carbon-carbon bonds are equal in length, intermediate between the carbon-carbon single bond and carbon-carbon double bonds. Physical properties of benzene. It is a colorless liquid with characteristic aromatic smell. Characteristic means that you either know how it smells or you don't know. You can only describe this smell by smelling it. B, it is insoluble in water, but soluble in organic solvents. Itself is a good solvent. C, it burns with a smoky, luminous flame. Industrial preparation. Benzene is obtained by catalytic dehalogenation of hexane from petroleum. Hexane plus a catalyst spit and heat first gets cyclohexane, and then further dehalogenation will give you benzene. Chemical properties. Benzene is not attacked by electrophilic reagents. In its reaction, benzene undergoes electrophilic substitution reactions in which a hydrogen atom is replaced by an electrophile rather than additional reaction where the ring will be destroyed. Reactions of benzene. 1. Combustion. Benzene reacts with oxygen to form carbon dioxide and water. Benzene plus oxygen will give you carbon dioxide and water. 2. Reduction. Benzene is reduced in the presence of a catalyst, that is platinum, to cyclohexane. Benzene plus hydrogen in presence of a catalyst will give you cyclohexane. 3. Aromatic electrophilic substitution reaction. Here, an electrophile replaces hydrogen atom on a benzene ring. General mechanism. Bond breaks, goes to an electrophile. Electrophile is positively charged. The positive goes there. Then there is a loss of a proton. We get an electrophile replaces hydrogen and a benzene ring. First double bond break and the pair of electrons donated to an electrophile. The positive charge goes there. Then loss of a proton leaves an electrophile substituting hydrogen atom. Nitration. This introduces a natural group on a benzene ring using a hot mixture of concentrated sulphuric acid and concentrated nitric acid. So benzene plus conc benzene plus conc nitric acid in the presence of conc sulphuric acid will give you nitro benzene. Will give you nitro benzene. Mechanism. The bond breaks, then we get then the benzene ring, then the benzene uses a pair of electrons, react with a nitro group, Then loss of a proton will give you nitro, benzene. When it is one group, you can put it anywhere on the benzene ring, nitro, benzene. Some people make a mistake and they don't know where to put the positive. In that case, you can write it generally as in case you don't know where to put the positive exactly, then just put the positive inside because the positive is also delocalized. The loss of a proton will give you nitro, benzene. If there's only one group on the benzene ring, you can write it anyway. Nitrobenzene is a yellow liquid. Therefore, this reaction can be used to distinguish benzene from cyclohexane. B. Sulfonation. This introduces a sulfonic group on the benzene ring by heating benzene with concentrated sulfuric acid at 95 and 110. So benzene ring, benzene plus sulfuric acid. This is concentrated conco. It will give you benzene, sulfonic acid, benzene plus conc sulfuric acid, heat will give you benzene sulfonic acid. Mechanism: sulfuric acid dissociates into then this double bond will break. There's a proton shift. Benzene sulfonic acid. C. Halogenation. D. This requires the use of electron carriers such as aluminium free chloride and iron free chloride as catalysts. The electron carriers function is to polarize the halogen molecule by withdrawing electrons from the bond between the two halogen atoms. Example, benzene plus chlorine in the presence of aluminium chloride free as a catalyst will give you chlorobenzene. Will give you chlorobenzene. Benzene plus chlorine in presence of electron carrier aluminium chloride will give you chlorobenzene. Mechanism. We say that when you don't know where the positive charge is going to be, you just put it in the middle. Then loss of a proton. Will give you chlorobenzene. Example 2, benzene plus bromine in the presence of iron-free bromide. You can pause, complete, and then compare your answer with mine. I hope you have got bromobenzene. Then the mechanism. One of the bond of the double bond breaks and the pair of electrons donated from any atom. Then this bond breaks, goes to iron free bromide. Then loss of a proton. Will give you bromobenzene. When there's only one group on the benzene ring, it can be written at any corner. D. Friedel-Crafts alkylation. This is the reaction of benzene with alkylhalide to give alkylbenzene. The reaction is catalyzed by an electron carrier. Example, benzene plus H3Cl in the presence of aluminium chloride will give you This is the methyl benzene. We'll give you methyl benzene, or the other name is toluene. Mechanism. The double bond breaks and a pair of electrons is donated to a carbon atom that carry a halogen atom. The bond between the carbon and a halogen atom also breaks. Then we get said if we don't know where the positive charge is supposed to be, we are not very sure, put it in the middle. We get an intermediate, then loss of a proton will give you methyl benzene. Methyl will give you methyl benzene. Benzene plus ethanoyl chloride will give you methyl phenyl ketone. Mechanism. The bond breaks and a pair of electrons is donated to the carbon atom carrying the chloride atom. The bond breaks. The positive charge goes there. Then loss of a proton will give you methyl phenyl ketone or phenyl ethanol or phenyl ethanol. F, reaction of benzene with alkenes. The reaction is catalyzed by an acid. An example, will give you to phenyl propane. Mechanism: propene will pick a proton, and this one will generate an electrophile. Will generate an electrophile. Then benzene will react with the electrophile. Loss of a proton will give you that one. Example 2. Benzene plus 2-methyl propene in the presence of an acid. Pause, complete, and then write a mechanism. Compare your answer with mine. I hope you have got mechanism. Generate an electrophile, then the benzene the double bond breaks and the pair electron donated to the electrophile. If you don't know where to put the positive charge, put it in the middle. Then subtract a proton. Then you get the product. Halogenation of benzene in the presence of UV light. Benzene reacts with chlorine by addition reaction to form a saturated compound. 1, 2, 3, 4, 5, 6 hexachlorocyclohexane. So benzene plus phenylchlorine will give you one, 2, 3, 4, 5, 6 hexa fluoro cyclo hexane. Thank you very much. Your teacher has been Dr. Bbosa Science, a teacher at the Science Foundation College, the best school in Uganda that teaches sciences. At O level, we teach arts and sciences. At A level, we teach sciences only. Join in today, 0776 802709 or 0753 80 2709.
Nze nemye nze ndeka redi enemye kandi rodi yanyiye duka ndikadde sakaki kali nemye ndikadde lindirira lulwo kandi rodi yemukadde mayumba ge mapya buli kimu akyetaaga buli kamwaka manja buli kamwaka nkanda ekonome yafa nali manyi maze okufuna wapya nali mbegomba abali n'abato nali netaasa era nesunga okufuna omupya gwoyita omukadde kuzize kwenkuwa ezandimukozeeko kwate zonsaba zokola oziwaani nga kapita omulya lwenti asaba bukadde mazzi ga bukadde yakawa bukadde ekyo kankiveeko genda yewana z'omuwala omuto teekwa kunjagala teekwa kunsasula laga waweepanka
lwaki wankwana zatalina buti sikyalira
mbeera nesunga buli omu akyetaaga okufuna omupya tulifuna omutuufu ndibeera omutuufu mutuufu yaani kyagula amanyi
koye ebibuuzo byo
nze nemye nze ndeka redi enemye kandi rodi yanyiye duka ndikadde sakaki kali nemye ndikadde lindirira lulwo wololololo nze kampuni enemye
kidedi
wololololo
nawe
omuwala nemye
bambi
wololololo
mukwano
kazira waka
komo
mukyala afumbe
sikamone
omuyamala
komo bambi
wololololo
bambi
nze ndeka
dadi
ono yamanyi
komo dadi
ebinkwatako
nawe
mukyala wawaka
bambi
yamanyi bwe twajja yamanyi bwe ndi wano